knowledge graph layer. We do not claim that this will be the solution to this problem, but we just say that this is a perspective that we can approach, from which we can approach this problem. And then they can do whatever they want with the core knowledge graph that we have. They can change the data, they can modify the data, they can also, which is more important, extract the meaningful insight or information. And for this, as an example, for this paper, we came up with this system architecture. So first we have the BIM data, the building model, and then we have some unstructured data like the work orders from the University of Toronto, and also we have the sensor data that we were provided with from the facilities and services of University of Toronto. And then we convert the BIM data and the work order data as examples of structured and unstructured data to knowledge graphs. And then we store them in the knowledge graph databases that we have. And then for the sensor data, we converted them, we stored them into relational databases, their timestamps, I mean, their readings. And then to extract the meaningful information or insight from this databases that we have, we used a multi-agent, LLM-based multi-agent system. So you can ask whatever question that you have, and it will come up with the answer to that question. So for knowledge graph construction, we modeled the Galbraith Building, which is the civil engineering department building at University of Toronto. It's like a 6-story building, a very, very big building actually. And we use the IFC schema here. However, this approach is not actually, it's kind of a schema agnostic approach. It does not rely actually only on IFC, but here, for the sake of the reproducibility, we use the IFC. So we converted that and we constructed the knowledge graph for that. Also, we have the work order data, and for those of you who might not be actually very familiar with the work orders, when you, for example, at your office where the temperature is very high, you will submit a ticket that it's too hot. So the work order will start there. It's like a small project. The facilities and services of the university will work on that, and it will contain all the data related to that, from the cost data, schedule data, and the teams that have been assigned to that problem until they resolve the problem. So that is like a small project. So we converted the work orders also to the knowledge graphs. Also, we had some condition assessment data, which are some reports from the assessors for all the university buildings and assets and entities, for all of them. Those are kind of textual and tabular reports. And also we had the sensor readings. We also converted them to knowledge graphs. For the sensors, we just stored the metadata of the sensors in the knowledge graph, and we stored the readings in the relational database. I will go into the details in the next slide. And then we combined all the different knowledge graphs that we had to come up with a unified final knowledge graph. So for more details, for example, for the work orders, we also added the taxonomy. We analyzed more than 80,000 of work orders from 2017, I guess, until 2024 at the University of Toronto to come up with a customized UofT tailored taxonomy. And this is an example of the knowledge graph of a specific work order. And here is a knowledge graph of a specific sensor for a room. As I told you, we stored the metadata for the sensors in the knowledge graph, but they do contain some references to their specific tables or sensor readings in the relational database, like this one. Using these references, it could refer to the a relational database. And this is another example. So in the upper picture, you can see that you know that this sensor, for example, is installed in this room, and you have the reference to the readings of that sensor in the relational database, so you can read that. And in more details, this is the way that we converted the BIM model to the knowledge graph. And on the row left, you can see an example of the IFC wall node. And for the work orders, again, we use the IFC schema because everybody knows that, but it's not actually limited to the IFC schema. And now, until now, we have all the information in the form of the knowledge graphs, but the more important thing is how to extract the meaningful information that you need for your analytics. So for that, we designed a multi-agent multi-agent system. It includes 3 agents for this specific paper. We also did some other works. You can come up with whatever agents that you want with the different tools and capabilities for them. So here we did use this system. Here, for example, is another example for another system. And then we also developed a web interface for the staff of facilities and services at University of Toronto to work with the model to have their feedback. This is an example of the thing that we created for them. So here we asked the question, show the chart of the sensor with this ID for the first week of February 2025. So it finds that sensor, it extracts the related data to that specific time span for that sensor, and also it creates using the Python, it creates a graph for that specific time span that you have. And here also another example which contains the reference to the work orders. So the question here is that investigate work order with this ID and provide insights into the reported issue. It says that, okay, this work order says that there have been like a high temperature, the room has been too hot. So it goes to the knowledge graph and to that work order, and it says that that work order is related to the specific room, and that in that room, it can see that we have this kind of installed sensors. So it reads those sensor references to the relational database that we have, and then it goes to the relational database and come up with the charts, if they make sense, for that sensor. So as I told you, I promised to be very quick, and that was it. Thank you very much for your attention.